to section B of this unit on position time graphs. So first thing, let me come around and check the homework that was due today. You can see that I asked you to bring a ruler and a protractor, and I've modified the plan a little bit so you will not need your own ruler and protractor till tomorrow's class. But it is imperative that you each have your own ruler to work with over the next couple days. You'll be needing it every day in class from tomorrow on. So please make sure you have your own here. You don't want to be borrowing things from me for class use because you won't be using those on a test. You have to have your own stuff. So I want you to get used to it and your own things. All right. So let's check our answers. To the review. I hit record, yeah, I tried it. All right, question 1. Asked you to define displacement in your own words. Displacement is a change in position. Number 2, if you wake up in the morning, you go to school, you go to the grocery store, and then you return to the same place where you woke up, what is your displacement for the day? It's 0 meters. That's because your initial and final positions are the same. So when we look at the change in that position, there isn't one. So it's 0 meters. Number 3, displacement is a vector quantity because it will include a direction. Number 4, can an object's displacement be negative? And what will the sign indicate? So yes, displacement can be negative. So a negative sign would tell you the direction that you moved in, whether it was left, down, west, or south. Number 5, can a distance ever be negative? And that answer is no, of course not, because distance is a scalar. It's just an amount. If it could, it would be like saying that your shirt size is negative medium. Does that make any sense? Does it make sense to say positive medium? Does it make sense to put a sign on a size? Magnitudes don't have a sign, but direction is that sign. So we would not put it there. We would just say medium. That's a scalar. Number 6, if someone told you that they traveled 50 kilometers east, are they describing the distance that they traveled or their displacement? And how do you know? That's a displacement because there was a direction on the measurement east. So it's a vector quantity. Number 7, when does an object's displacement and distance traveled, when are those different? They're different when the object changes direction. So let's say you have something traveling to the right and then it turns around and goes to the left. Then we can see that those values, those magnitudes are different sizes. All right, number 8 required some math. Number 8 says to draw a vector diagram for a person that goes 3 meters north and 5 meters east. And how would you determine the displacement for this person? All right, so to get the vector diagram, we start by showing an arrow going up. So we do need an arrowhead on it, otherwise it's not a vector. You would just be telling me you have 3 meters, but 3 meters in what direction? North is up on our page, so we label that arrow 3 meters. Then we have another arrow pointing to the right from there, which is 5 meters. Again, you need to have those 2 arrowheads or this vector diagram would be marked incorrect. Our displacement goes from our start to our end position. It is the hypotenuse of this right triangle. And notice the arrowhead here is pointing to the end location. It always goes to the end. So to find the magnitude of that displacement, we're going to use Pythagorean theorem because that is the hypotenuse of a right triangle. A squared plus b squared equals c squared is the equation we're going to use. We'll now plug in 3 meters, that quantity squared, plus 5 meters, that quantity squared is the displacement squared. So the displacement rounded to the same precision as the data is 6 meters. Now, because it is a vector, it means I also have to find the direction that this person walked in from start to end. The direction is an angle measure, and we always measure our angles from the positive x-axis going counterclockwise around the origin. So the angle I need to determine is this angle right here, from the positive x up to this displacement vector. Notice that angle is not inside the triangle. So we have to find where is that angle inside the triangle. It's up here. And why is it up here? Because these two angles are called alternate interior or opposite interior angles. So these two angles are congruent, which means I'm going to calculate that angle, and that would be the same as this angle. To do that, we've learned we're going to use our inverse tangent equation. So the angle is the inverse tangent of the opposite side length over the adjacent side length. So that means we're going to do the inverse tan of 3 meters over 5 meters, which gives us an angle of 31 degrees. So that means our displacement in this problem is 6 meters, comma, 31 degrees. The last question, bless you, it asks you to define a time interval in your own words. A time interval just refers to the amount of time between your start and end locations. So you're timing how long it takes to go from here up and over. We do not stop the stopwatch until the person reaches this point here. So it's the amount of time between our starting and ending positions or our initial and final positions. Okay, any questions on the homework? All right, then let's continue in our packet where we left off the other day, which is with question 6 on page, what page is that? It's up in the upper right corner. 4, page 4. Question 6. Actually, before we do that, before we go to question 6, could you turn in your reference table? I forgot to have you check some stuff off here the other day. With these right triangles that we're working with, there are some equations in our reference table on page 5 that we're going to be using where the geometry and trigonometry stuff is. So the triangles that sometimes we have are right triangles. And if we have a right triangle, we know that we can find one of the sides if I know the other two using the Pythagorean theorem. So let's check that equation off. The other one that we're using to help us determine the angle in the triangle, since we give you the two side lengths, is the tangent equation, but we manipulate that to solve for the angle by bringing the tangent function to the other side, and that becomes an inverse tangent of the opposite side length over the adjacent side length. So on this picture, side A represents the opposite side, B represents the adjacent side, and C represents the hypotenuse of this particular right triangle. So now you have that, and you have that in your on your reference table to help you with in-class work, homework, quizzes, that kind of thing. You'll need to know to use it when we go to take a test because it won't be on your reference table then. Well, this part is. You just have to know to get there. All right, back to question 6 now. Number 6 says that we have a local sign company needing to install a new billboard. And the signpost happens to be 30 meters tall. Can you please make that 30 point meters? And a ladder truck is going to be parked 24 meters away from the bottom of the post because there's an uneven ravine. All right, let's try to sketch that out. Let's say this is the ravine. Here is the signpost. The truck is going to park itself over here. This signpost is 30 point meters. And from the bottom of the signpost to where the truck is parked, that is 24 meters. Now, I want to know how long the ladder has to be from the back of the truck up to the top of the signpost. Let's call that a distance of L. Any ideas how we can find that? What equation can we write to help us find the length of that ladder, L, in that picture? Who knows? No one? Oh, come on. I don't think you're thinking hard enough. Look at that picture. What shape is this? Okay. You have a reference table that can give you equations for right triangles, and we just check stuff off. Which one of those are you going to use to find the hypotenuse of this triangle, Liam? Good. So let's plug in 30 point meters, that amount squared, plus 24 meters, that amount squared, is the length that we're looking for squared. Go ahead and figure out how long is that ladder. Yep.
Wouldn't it change because like you're starting from the bottom of the truck. That's the 24, right? And then when you go to the top of the truck, like you're not stuck.
That's the same thing. It's still 24.
I don't know.
That's the same thing. What is the length of that ladder? Now notice that both measurements go to the nearest meter, which means your answer should also get rounded to the nearest meter. Manor, can you tell me what you got for the length of the ladder? Okay. That's right. 38 meters is correct. All right. Number 7. In order to hike around a portion of Lake Allatoona, which is outside of Atlanta, a tour guide determines that he must take his group 150 meters east. Please make that 150 point meters east. They're then going to have to go 60 point meters north, and add the decimal point here, and then 75 meters west. I want to know what's the displacement of that tour group from its initial to final position on the opposite side of the lake. All right, so let's make a diagram to show what's going on. Let's say this is the lake. The tour guide starts here, and they have to go 150 point meters to the east. That means we have an arrow drawn to the right, which is 150 point meters. Now, which way are they going to go? 60 point meters to the north, which is straight up on our page. And then 75 meters to the west, which would be drawn to the left. Now, if I'm looking for the displacement, that displacement goes from our starting point here to the ending point here. This is our initial position. That is our final position. I am looking for this vector right there. That arrow I just drew. That is the displacement that I'm looking for. What is the displacement from the starting to the ending location? Add a question mark to that. Now, if you look back at all the other problems we've done so far, like in question 6 and 5 and 4, what shape were we working with every time? We had a right triangle. We need a triangle. I don't see a triangle in that picture just yet. That's a trapezoid. You should be able to make a triangle out of that, though, a right triangle. Any ideas what you can do to create a right triangle in this picture? Anson? Okay, but where, I need to draw the triangle. Where am I, what do I do to make the triangle there? Yeah, we're going to take a line. I'm going to draw this in red on my paper so you can see it a little bit better on the screen. We're going to drop a line coming straight down from the end of that 75 meter vector. And now we should be able to see that there is our right triangle. You see it? Okay, tell me what the lengths are. So this arrow now pointing to the right is a net amount of how much? How much is this arrow pointing to the right in that triangle? 75 meters, let's label it. How much is the amount going up on this side of the triangle? 60 point meters. Let's label that. Okay, this is a two-part question because displacement is a vector. So the first thing you have to do is you have to find the magnitude of the displacement. That means how big is that arrow for the displacement? What equation would we write to help us find the length of that displacement arrow? Carolyn? Yep, you're going to write the Pythagorean theorem. A squared plus B squared equals C squared. In other words, you're going to take 75 meters, square that amount, add it to 60 point meters, square that amount, and that would give you the displacement squared. All right, figure out what the displacement is. Each of these measurements goes to the nearest meter, so your answer will also go to the nearest meter. How big is that displacement? How long is the displacement arrow in the picture? Aiden, do you have it?
96 meters.
That's correct. 96 meters in length. But now it's a vector. You should be able to determine the direction of that displacement like we did in the homework question. We start in the positive x direction. Positive x is the same as east. We start there, we go about the origin, which is our initial position, and we rotate around counterclockwise until we get to the displacement vector. So that angle theta right there inside that right triangle is the one I want to find. That is our direction. So we're now going to find the direction of the displacement. And on our reference table, we wrote the equation that we're going to use to help us get that direction. We're going to set the angle equal to the inverse tangent of the opposite side length over the adjacent side length. That means in this problem, we're going to do the inverse tan of what over what? What goes inside those parentheses? Braden?
60 is the opposite, and the adjacent is 75.
That's right. So we're going to put 60 point meters over 75 meters. Now the meters will cancel. So let's go ahead, work that out on your calculator. We've done this before, so I don't think I have to instruct you on how to type that in. I hope not. I hope we remember. And what does that give us for the direction of that displacement? And of course, remember, we do all of our angles to the nearest degree. To the nearest degree, please. Dominic, can you tell me what you got?
39.
That is correct. 39 degrees. This is in the first quadrant, so that's good because positive x is 0. Straight up would be 90. So it's somewhere between 0 and 90, and it is. So the way we quote our final answer for the displacement is that our ending position is 96 meters at 39 degrees away. That is our final answer for the displacement of this tour group.
Was it plus?
Plus would mean right or up. It's neither of those. Okay, so it's an angle. Once you put an angle, we don't put any signs. It's one or the other, not both. Okay. Any questions on this? All right, so this is what you do when you have a displacement that's in the first quadrant. We're not always going to have that. But I'd like us to do the next 2 pages, use the ruler and protractor. Like I said, I'm going to save that for tomorrow. What I want us to do is now just do more of this, but for the other quadrants, because it's a little different once you have something displacing itself like north and west, or something that's going west and south, or east and south. So I want to go over that process because there's one additional step for those other quadrants. So this is where we're now going to go back to our notes and we're going to look at another example. Okay, so in your notebook, let's keep going with some example questions for these right triangle displacements. But this time, let's say I have a person that walks 4 meters to the west, and then they go let's say 3 meters to the south. What is this person's actual displacement if they walked 4 meters west and then 3 meters south? So like all the other questions, we're going to start by sketching it out. Quick sketch. This is our positive x direction, which is east. So they start off at the origin and they're going to go 4 meters to the west. Which way is west? Left. So we're going to draw a nice arrow pointing to the west, and we're going to label that 4 meters. We don't have to write west after it because we know that is the west direction. We have an arrow on it, which is pointing that way, opposite of east. 3 meters south means I'm going to go which way now? Down on our page. An arrow pointing down at the tip of the 4 meter arrow. So that is 3 meters in length. The displacement we're looking for is this arrow from the origin to the tip of our 3 meter arrow. That is the displacement that we want. The first step is to find the magnitude of the displacement. That should be nice and easy. That's the easy part that doesn't change. It's a right triangle. How do you find the length of that displacement arrow? Eileen, can you tell me? How do I find the length of that displacement arrow? Pythagorean theorem. Very good. A squared plus b squared equals c squared. So we're going to do 4 meters, that amount squared, plus 3 meters, that amount squared is equal to the displacement squared. Okay, what is the magnitude of this displacement? How long is that displacement arrow? Some of you may already know, don't even necessarily need the calculator, but go ahead and calculate it if you need to, if it's not hitting you in the face, what size that has to be. Jacoby, what is it? It's got to be 5 meters because this is a 3, 4, 5 right triangle. Okay, but now we have to find the direction of the displacement. This involves a couple of steps. First thing I want you to do is look at what quadrant this displacement vector is pointing in. What quadrant is this vector in? Yeah, it's quadrant 3. This direction is 180 degrees. That direction is 270. It's in between left and down. So our final direction has to be something between 180 and 270. This is a quadrant 3 problem. So the angle that we need to get in the end is somewhere between 180 and 270 degrees. Using your sine, cosine, and tangent functions, you can't get that. You can't get angles between 180 and 270 in one step. You can only get angles between 0 and 90. That's it. So what we're going to do whenever I have a triangle that is outside the first quadrant is I'm going to calculate what we call the reference angle. This angle here inside the triangle connected to the horizontal axis. I'm going to call that angle alpha. So we're going to start by finding angle alpha using that inverse tangent equation that we wrote on the reference table. That the reference angle we're looking for inside the triangle is the inverse tan of the opposite over the adjacent side. That means we're going to do the inverse tangent of 3 meters over 4 meters. Okay. Go ahead and figure out what that angle must be then. Alexis, do you have it?
37.
That's correct. Now, obviously, that's not the direction because it's not between 180 and 270, right? Okay, we have to figure out how do we get the direction we want. What we talked about, the convention for our directions is we always start at the positive x. So put your pencil on the positive x. You're now going to rotate around the origin counterclockwise. Go around until you get to the displacement vector right here. That large arc we just sketched is the angle we need. Now remember, if I just rotate from here to here, how many degrees did I just do? 180. I didn't stop there. I went beyond 180 by the amount we just calculated. Thanks, Noah. I went beyond the 180 by the amount we just calculated. So any ideas on what I can do to get the large arc that I need, Liam?
Add 180, 37.
Yeah, so to get the angle, and we're going to show the math, we're going to take the 180 degrees, which is the top half of the arc, and add 37 degrees to it. And that will put us in the third quadrant. So what does that mean the direction of this displacement is? Angela, do you have it? That's right, 217 degrees. So our final answer for the displacement is 5 meters, comma, 217 degrees. I realized I skipped the second quadrant. So let's go back and try one there. Any questions on the third quadrant one I just did? Second quadrant is very similar. Let's say I go 5 meters west, and then I go 6 meters north. What is that displacement? Set it up the same way. Sketch it out on your XY axes. So 5 meters west would go to the left. 6 meters north is going to go straight up. So our displacement starts at the origin and goes up and left. It's that arrow pointing to our end location. That is the displacement you are looking for. First thing you're going to do is find the magnitude of the displacement. What equation are we going to use to get that? Anya, can you tell me? Yeah, a squared plus b squared equals c squared. All right, so that means we're going to take 5 meters, square it, add it to 6 meters squared. That's going to give us our displacement squared. So now we got to figure out what our displacement is to the nearest meter, because each of those went to the nearest meter. Miranda, what are you getting for that displacement to the nearest meter? 8 meters. Very good. All right. Now we got to come up to the direction piece of things. Find the direction of the displacement. If I start at the positive x and I go around the origin and I go around counterclockwise till I get to the displacement, that arc is the angle I need. That's the angle I need. But what quadrant did I say this one's in? Quadrant 2, which means that angle is somewhere between 90 degrees and 180 degrees. So we can't calculate it in one step. All we can find and calculate with a trig equation is the one with the horizontal that is inside the triangle. That arc right there. And I'm going to call that alpha again. Do you see it? This is the angle inside the triangle with the horizontal. That's the one you can calculate using the equation we know. What equation do we know? We know our inverse tangent of the opposite over the adjacent side will give us the angle our reference angle. Let's go ahead and plug in. That means we're going to do 6 meters over 5 meters. What is that angle? To the nearest degree, please. Lucy, do you have it? Yeah, so to nearest degree, I'd write it as 50 point degrees. Okay. Otherwise, it's to the 10 instead of the 1, which is what we're looking for. But that's fine. All right. Now, any ideas how we can get theta? Look at theta and alpha together. We just said this is 50. That's right, because we know to this line, all the way around is 180. We got to back up by the 50 to get us where we need to stop. Is everybody with me on that? You see it? So that means to get the angle we're looking for, take the 180 degrees going west and back up by 50 degrees, which means the direction of this displacement vector, Gianni, is how much? Good. So that means the answer to this problem is 8 meters, 130 degrees. Okay? Yeah? All right. I'm going to give you one more, and I want you to try it on your own. And then we'll compare. Solutions. Now, I'm going to tell you right now, these problems are not necessarily about can you just get the right answer. I need to see all your work to get there. That's what's going to get you all the points on a test or a quiz. It's very little about do you have the final answer right. You get like 1 point out of 10 for the final answer being right. All this work to get you there, all the other stuff I did here is worth the 9 points. That's only worth 1 out of 10. So if all you get is the right answer, you got a 10%. I don't think any of you want a 10% on a test. It's pretty hard to come back from that. So let's try this example. Let's say we're going to go 12 meters to the east, and then we're going to go 15 meters to the south. What is the displacement? Give you a few minutes to try to figure this out on your own with all the steps. I'll make sure everyone has had time to work this out. Anyone need more time? All right, let's check your work. Okay, first thing, let's check your sketch. Does it look like that? You have 12 meters to the right, 15 meters down, displacement arrow pointing down and right. The angle we're going to have to calculate is that angle in here, alpha, but the final direction is that large arc, theta. Okay, let's take our break. We'll finish going over the rest of this after the break.
Prior to teaching.
Bro, just like keep us indoors. Just like put us in the bed or like, bro, 90% of the stuff we do at practice for reading can be done inside.
That's true.
You're not, it's that you're doing please. You just need a little bit of room. That's it.
Oh,
The kickers just won't pick. We're not jobs. Huh? Velcro's good at kicking. It's just like. I mean, you can't do everything, but if you let them, you know, that's okay. But it's also nice first year, and coach isn't going to put Cam as our kicker.
I agree.
I agree, but
It's a good thing, too. It's just recently. I forgot how many kicks. 30 yards? 40?
the kids also been kicking since he was back. Tyler's only been playing baseball since he was 3. I was never a football kid.
I know, I heard that. This is the first year.
Yeah.
It's pretty good. Roush. It's good.
Not bad.
It's really fast.
Yeah.
An hour a day.
It's gonna be like an hour.
All right. Come on in back. Come on in. All right, let's finish out reviewing this question. So we have our sketch, which means the first thing you're going to do is you're going to now find the magnitude of your displacement, and you should have started with the Pythagorean theorem equation. If you did not show a squared plus b squared equals c squared, you would lose credit. Then you have to show the 12 meters getting squared plus the 15 meters getting squared equaling the displacement squared. You do need parentheses, as I've shown there. If you left off the parentheses, you're telling me you had 12 square meters. You had an area of 12. You wouldn't be squaring the 12 in your calculator. Same thing with the 15. You got to have the parentheses around the 15 meters. That gives you a displacement of 19 meters. How are we doing so far? That was the easy part. Now we got to come up with that angle inside the triangle. We should have realized, first of all, this is quadrant 4. Quadrant 4 angles are between 270 and 360 degrees. So to get the reference angle inside the triangle, you should have shown the equation. Alpha is the inverse tan of opposite over adjacent. Now we're going to plug in inverse tangent of 15 meters over 12 meters. That gives you an angle of 51 degrees on your calculator. All right, now what are you going to do to get the actual direction? Can anybody tell me? What do you do to get the actual direction? Braden?
Minus 51 by 360.
So the other way around, otherwise you're going to get a negative angle. 360 degrees minus 51. The reason you're doing that is because 360 is all the way over here. We have to back up by that angle alpha. Or notice that theta and alpha together produce the circle, the full 360. So we got to take alpha away from 360. That gives us an angle of 309. So your final answer that you should have boxed in was 19 meters, 309 degrees. How many of you got that? Good. Good. There's lots of them like this. Tomorrow, we're going to tackle what do you do when it's not a right triangle? And this is why we need rulers and protractors. We don't have equations that will work for that. Okay, not in this course. If you've done laws of sines and cosines, then you could do that, but not here. You're going to do it with rulers and protractors. Draw it all out. Okay? And that's what we'll learn how to do tomorrow. The rest of our time today is for lab number 4. We're going to start 4 today. We're going to finish it on Monday. Please put everything away right now except a pencil. Everything away except a pencil. While you're doing that, let me just make a quick comment about yesterday's test. They are graded. You should have seen the grades in Aspen if you looked. They're there. These are the grades before you do test corrections if you're eligible to do test corrections. You are only eligible to do test corrections if you made a mistake on a multiple choice problem. You made errors on constructed response. There was partial credit on all the constructed response questions. So I don't let you do test corrections on that. I showed you what you had to do. Okay, so the multiple choice is what you can correct. All my students just finished taking the test, so the test will be handed back tomorrow. And so tomorrow you can see what you got right, what you got wrong. A lot of you are going to be doing this to yourself after you get the test back. You know why? Because you didn't read the directions to the questions as to what I needed to see. I told you everything I needed to see on a question. And if you just decided not to show it, bingo, you know points are going to get taken off. Okay, I can't make it any clearer. So just a pencil. You are actually going to pick up and move in a minute. You're going to take all your stuff with you. That's why I said pack up your stuff except for a pencil right now. All right, what we're going to do with Lab 4 is we are going to collect, we need 6 set of data points. But instead of each of you doing this lab 6 times, you're going to work in a group to collect 1 set of points. And then we'll have 6 groups. So we'll just share everybody's data together to give us 6 sets of points. Does that sound like a good idea? That way we're not wasting time just doing all that. All right. So to do that, we're going to count off to 6. We're going to just. Okay, so I'm going to now ask you to pick up and move. I would like all the 1s to sit here. All the 2s can sit here. All the 3s can sit here. All the 4s can sit on those 2 benches. The 5s on those 2 benches and the 6s on those 2 benches. Pick up and move. Okay. Each group is getting 1 set of Post-it notes. That person who I'm handing the Post-it note package to goes to group of 3. Yes? So that's group 1, group 2, group 3. You're in charge of the Post-its. Okay, those of you with the Post-its, you got your pencil? Let's start writing. On the first Post-it, I want you to write 0S. Nice and big so you can see it. Then go to the Post-it underneath that. You're going to keep them together. Just lift up. On the next one, write 2S. That's fine. That's good. Just so you can see it. You don't want it itty bitty because then you'll have a hard time reading these in the hallway on the floor. So we have a 0S Post-it, a 2S Post-it. The next one is 4S. Guess what the next one is? 6S, S for seconds. Keep going all the way till you get to 12 seconds. Okay? 0, 2, 4, 6, 8, 10, and 12 seconds. Then you can take that Post-its, take those that you just marked on, take them off the rat, and I'll take the rest of the Post-its from you. Thank you. Thank you. Now you're not done writing on those Post-its yet. Now you got to write on the Post-it. Each group is going to be given a cart or a buggy. Okay. They turn on and off on the side. There's an on-off switch. Okay. When I give you a buggy, it has a number on it. every post-it needs that buggy number on it somewhere. Okay? You guys are going to be buggy 3. So put a 3 on every single one of those, like in the bottom corner. The folks at group 4.
Does it?
The reason we're doing this is because there's gonna all these post-its are gonna be on the floor in the hallway, and we're gonna need to know what post-it belongs to what buggy. Okay, you guys have 1. Well, and you guys have buggy 6. 6. Okay. Next thing. One person in the group is going to be the timer. So you've got the post-its, you have the buggy, you're the timer. You need a Chromebook for this. So post-its, buggy, timer. Post-it, buggy, timer. Post-it, buggy, timer. You need a Chromebook. The post-it, buggy, you need your Chromebook. Go ahead, pull it out. Yeah, you got your Chromebook. What I'd like you to do, those of you with the Chromebook, we need a stopwatch. So go open up a Google Chrome tab. Open up a Chrome tab and just type in stopwatch. And you should get a link to a stopwatch app. Yeah? Just open up a stopwatch. And all you're going to be doing with that, do you know how to start it and stop it and reset it? Great. So those of you with the timer, this is your job. You're going to say, start. And then you're going to watch it. And when you see it hit 2 seconds, you guys go 2 seconds, 4 seconds, 6 seconds, all the way till this one. Well, okay, you don't have to say seconds. You just go 2, 4, 6, 8. It goes fast. They happen quick. Those of you with the post-its, this is what you're going to be doing. Oh, watch this. So let's say this buggy is moving along. We have to mark where the buggy is on the floor at 0 seconds. That's the easy one. So go ahead, just pretend. Okay, that's the easy one. Sure, the front. We're going to be try to do. Okay, so I want you to start the timer. Ready? And you're going to call out 2 seconds. At 2 seconds, wherever this is, you got to put that post-it down. Okay. Ready? Go. And then you will do it again at 4 and at 6 and at okay. Yeah, this gets to be kind of funny, okay? Because you got to get them all down. Now you're going to be doing it in the hallway on the floor. So here's okay. So wait a second. Does everybody have a job? Except for you.
Jacoby.
Your job, Jacoby, is to be making sure this bad boy is going straight. The person who is timing, your job is to watch that clock and call off the times. Those of you with the post-its, those of you who had the buggy, your job is also to help make sure it goes straight. Okay? Yeah. All right. Now, don't worry. I am going to show you exactly what we're doing in the hallway. Okay. Everyone needs to bring their pencil out with them to the hallway. Because then we have another job once we get all these post-its on the ground. Come on out to the hallway. This will be fun. Where is buggy 1? Buggy 1. Okay, buggy 1. Come on down here. Oh, buggy 1. Number 1. Okay, 25. 25. You're gonna start here and here. Going that way. All right, 26. Yours is the hardest one. Yours is going to be at 6 meters. At 0 seconds.
It's not fun.
Okay, so at 6 meters, count off your number 2. Don't knock yourself. Watch this one, everybody.
Three, two, one, go.
2, 4, beautiful. Okay, now you all have the job. Everybody here. See all these post-its here. Okay, you want to try to do this for your group's post-its, but if you end up helping another group, I really don't care. Every post-it needs to get the position on this 10-meter measuring tape marked on it. In center. Let me show you what I mean. So you can close up your Chromebooks, you don't need those, put the buggies off to the side, get those committed. Follow me here to this one here that says 6 seconds for buggy 5. Everybody come around, I'll show you what you're doing. We're going to write on this what position this is at. The first thing we have to do is look for the red number around it. See, there's a 6 meter here and a 7 meter there. 6 meters is 600. That's 700. So the first number we're going to put is a 6. Now we're going to count the number of centimeters, which are the marked lines on here. So this is 10. That's 20. That's 30. So if it were here, I would say it was at 620. But notice this, let's say it was there. Then it would be 620. That's what we would write. 624 on the post. This one, what are we going to write? 600. The middle of the post is right around here. So I would say 608. 608 on this post. So they can write that on this one right now. We're going to get all the other three. Okay? Go ahead, get those done, and then pick them up once you've written on it for your buddy.
I have a feeling.
I'll grab the buggy. Help, so if yours are all done, help another group get theirs. And then stack them up. Pick them up, stack them up. Once they have a measurement, they can walk to the floor. Just right position on. There's 12, there's one there that needs to right number 800. Where's Buggy 5? Where's the Buggy? And I'm putting an order from 0 to 12. That all? Okay, so put your rubbish head back into the room, sit in your room. And everybody
You're just so funny. I cannot figure out how to do it. I'm just laughing at working.
Okay, can you all open up your Chromebook now to lab 4? That was kind of fun, right? Fun and silly. We do a lot of labs with toys in physics. So that's one of many toys that we work with over the year. All right. So lab 4. Open it up. And what we're going to do is we're all going to type in the data together for all of these. I just have to make a copy so I don't edit my template. It's just raining, folks. Yeah, raining buckets. All right. So what we need to do, folks, is look at this tab in your lab, the experiment tab. Let me make this larger right here and increase the size 150. That's good. All we're going to do now is populate this data table with the positions that you marked on those Post-its for your buggy, okay, in chronological sequence 0 to 12 seconds. So let's start with buggy 1. Buggy 1, time 0. Well, who has buggy 1? Okay, time 0, Caroline. Okay, that's easy. 2, 40, 4, 71, 10, and 12. 181. Okay. All right, buggy 2. Where's buggy 2? All right, go ahead, Angela. Read those off nice and loud. Yep. 4, 6, 8, 10, and 12. Cool. All right. Buggy 3. Okay, go ahead, Morgan. Read them off nice and loud.
1,000.
Yep.
947.
Yep.
884.
Yep. Number 6.
836.
8.
836. Okay. And then 8 is 887.
I'm sorry.
887.
Can't be. Out what happened? Buggy 4. Who's got Buggy 4? Okay, Anya, read those off.
1,000.
Yep.
800.
Yep.
784. 580.
580.
Yeah.
Okay, 10 seconds.
485.
Yep. And 12.
375.
Okay. Buggy 5. Where's Buggy? I'm sorry.
300,
Yep.
440,
440.
539,
Yep.
612,
Yep.
705,
Yep.
805,
Yep.
and 920.
920. Okay. Hardest buggy of all. 6. 600. 600. Okay. And the reason we need that is because we want to look at what position time graphs will look like for something that doesn't move versus something that did move, and different directions of motion and speeds. So this is going to help us. We saw how they were all moving. We get to kind of visualize now what a graph would look like, and that will be part of what we do on Monday. All right, Morgan, have you figured out what the deal is?
Okay, so 8 seconds is 807.
Yep.
10 seconds is 747.
Whoops, 747. Yep.
And then the last one is 709.
Okay. I'll collect those Post-its from you. Oh, we got a lot of time. Okay. Do the next step. Let's get those Post-its. We don't need those anymore. All right. So now what we're going to do, and this is going to look really funky. We're now going to make a graph that goes with all of that data, and all 6 buggies are going to be on the same graph grid. So what we usually do when that happens, when we plot multiple data sets on one grid, is we get different colored data points, and there's what's called a legend. It's a key, which tells us what's what. But because we're putting multiple data sets, Google Sheets doesn't like this. It's not going to create the kind of graph we want. It's going to create a bar chart for us. That's not what we want. So follow along with me. I'll show you how to make this graph, okay? Please put your cursor in cell A2. So it's actually A23 in the name box. Hold down your shift key, right arrow over, and it should select all the positions and the car numbers. Yes. Down arrow, holding down your shift key until you get to cell G10. So now your name box on the top left says A2:G10. Yes? Good? Okay. Insert chart. I told you. Is that the kind of graph we want? No. So we have to now do a lot of customization. So follow along with me. I'll go at a moderate pace. You see in the chart editor, there's actually two options, setup and customize. We have to go to setup first. Under setup, change the chart type. And you're going to scroll down. We do not want column. Scroll down until you see scatter. There are 2 options under scatter. You want the one on the left. So when you hover over it, you see it pops up and says scatter chart. That's the one you want. Select that. Okay, now continue down with me. You should have these same labels. For the x-axis, it should say time in seconds. And then for series, you should see car 1, 2, 3, 4, 5, 6. Those should be named. If they're not, we missed something. We have to delete the graph and start over. Is everybody good? Yes? Okay. Now, let me see if there's anything else. Now, it should have checked use column A as labels at the bottom. Did it have that checked for you already? Okay. Go to your customize option. There is nothing labeled on this graph at all. So we have to label everything. Start with the submenu chart and axis titles, please. Let's start with the chart title. Notice it's blank. Please type position versus time. This is a position versus time graph that we just created. Okay, come back here, hit the down arrow, and now select horizontal axis title, please. We're going to type the title text is time, parentheses S, seconds. Enter. Now hit that down arrow again, go to the vertical axis title. The vertical axis title we're going to type is position, and the units of this are cm, centimeters. Okay, collapse that submenu. I have to make my screen a little bit smaller, otherwise I can't see the whole graph to make sure we're doing everything. You should have a legend here on the right, so it's telling you what color dots are which car. I have my 0, 0 on the bottom left. That's what I want. That all looks good. Now we have to add the trend lines. Okay, I'm going to double click on this. Where do we add trend lines? Under series. And it should say apply to all series. Okay. Head on down, select the trend line option. These all should be linear. We want the default. And for the label, I want you to say use equation. That's it. This graph is now done. Let me make my screen a little smaller, and I'm going to ask you to move it because we do not want to cover up the data table. Please click on your graph and move it into the yellow box here where it asks for your graph. I can't go any. Can I go lower? No, I can't. So I'm going to resize this. You can resize your graph by clicking on the dots. You can make it longer like that. You can make it taller or shorter. I think that's good enough. Why isn't it fitting all? Yeah, that's good. It's fitting in that yellow box. That's what I want. Okay, how are we doing? Do we want to start working on these equations? Why not? Okay, on the right side, it asks us to write the equations for each car. Now, do you remember how we modify these equations? Google Sheets gave us an equation. Let's look at car 1 for a minute. We should all have the same equation because we all have the same numbers. It should say 14.6 times x plus 8.29. Is that correct? Okay. Remember, that's equal to the y. What's the y variable on this graph? The name of the y variable, Angela? Position. Okay, so when we start typing our equation here, and for the purposes of this, to make it easier for all of us, I'm going to drag my graph up. That way it's next to these equation boxes. You don't have to do it. You can just see it up here on the screen. So here, I'm going to start by typing the word position equals. Now we're going to take that number. We are going to add a plus sign in front of it because this line went up. The plus, we're going to learn what that means as we start to analyze this graph later. But we need the plus sign, 14.6. Now we got to come up with units. That's the slope. Anybody remember how we're going to get the units of this slope? So if we look at the y-axis, what are the units on the y-axis? Anson? Yeah, so we take the units of the y over the units of the x. So that would be cm slash s. Then we close our parenthesis. Now we're going to change the letter x to the name of the variable on the x-axis, which is time plus, we keep the number 8.29, but that's the y-intercept. What are the units of those y coordinates? cm. So we're going to add cm after that. Enter. And that is our equation for car 1. Do you think you can do that for the other cars? Okay, why don't we go ahead and work on that? So car 2, position equals positive 42 cm over s times time plus 17.8 cm. Car 3 would be position equals, oh, notice now we have a negative slope. Plus 992. Car 4, position equals negative 50.4 cm over s times time plus 986 cm. 5 would be position equals positive 49.2 cm over s times time plus 322 cm. And car 6, position equals 0 cm over s times time plus 600 cm. I think that's all of it. So I'm going to move this graph back down. And that's where we're going to stop. We're not going to do any more with this today. Okay, so just make sure you finish up those equations for all 6 cars. You getting this? Did you get the same equations I did? If you didn't, it means we typed something in wrong. Okay. Google Sheets did not give you those same equations. And that's where we're going to stop for today. Do not turn this in. We are not done. We have 2 more tabs to do, analysis and conclusions. But we'll tackle all that Monday. All right? What's your homework for tomorrow? You've got 2 things you have to do for tomorrow. Who can tell me one of the 2 things you have to do for tomorrow? Remember?
Bring a protractor.
And, yep, ruler and protractor. You can't do the lesson with just a protractor tomorrow. You need both. Ruler and protractor is one of the assignments. What's the other thing I told you to do for tomorrow? Starts with an S. Study. Study your notes on position, distance, and displacement. Okay, study your notes on position, distance, and displacement because we will be continuing our work with position, distance, and displacement, but learning how to solve these questions in another way that involves drawing everything out tomorrow. So what we've already talked about is kind of like the end of things. We're still talking about the same stuff, but we're going to learn how to solve them a different way. Okay. Any questions for me? All right. Good class. That was fun.